So we're going to get started here right away. What we're doing is adding and subtracting fractions with unlike denominators, which is very similar to adding and subtracting like denominators because all we need to do is change the unlike denominators to be like, and then the process is just the same. Let's get quickly started with addition. 1/4 plus 3/8. Now, like I always like to do, I like to make my first step to be making this horizontal problem vertical. So I'm going to do that now. 1/4 plus 3/8. And I'm going to draw a sum line. Since I've got that, I'm already done with that, and I'm going to eliminate this section here. And then, after elimination, I'm ready to grab this and move it up high so that I have room. Now I'm ready to work. Now, because we have unlike denominators, we need to find a common denominator, and then we're ready to work. So let's first find a common denominator. We can look at 4 and 8 and think about what a common multiple of 4 and 8 would be, or we could use multiplication. Multiply the 4 by the 8 and the 8 by the 4 and get an equivalent. So that's what I'm going to do. I'm going to do exactly what I just said. I'm going to extend my line here, and I'm going to multiply this by the opposite denominator. So since the opposite one is 8, I'm going to multiply by 8 on both sides, just like we did previously if you've been watching these videos sequentially, or you've been in my class. Then we do the opposite. For this one, we extend the line and we multiply by the opposite denominator. Multiply by 4 here and multiply by 4 in the denominator as well. And as you can see, we have in the denominator 4 times 8 and 8 times 4, which will eventually equal a common denominator. Now, we write the equal sign so that we can see the new problem. 1 times 8 equals 8 over 4 times 8 equals 32. Then we do the next one. Equals 3 times 4 equals 12 over 8 times 4 equals 32. And as you can see, I did this in green because now we're good to go. We have common denominators, and now we're ready to perform our operation. Check back. Always make sure you're looking at the correct one. So I'm going to bring that plus sign over here. And it's a little bit crunched. You can space yours out more. It doesn't have to be so close together. I'm working with less space in general. But now I'm ready to answer the problem. Because the denominators are the same, I know that I only need to add the numerators, which are 8 and 12. Now I'm going to do that. 8 plus 12 equals 20. And that's over 32 because the denominators are the same. Now, the last step when adding and subtracting fractions is simplification. We need to check to see if we can simplify here. So, think, are there any common factors of 20 and 32? And furthermore, do you know the greatest common factor? you can quickly tell that a common factor is 4. 20 is divisible by 4, and 32 is divisible by 4. So I'm going to do just that. I'm going to extend, and I will divide by 4 by the numerator and divide by 4 in the denominator. And I'm going to write an equal sign, and I have my operation now. 20 divided by 4 equals 5 over 32 divided by 4 equals 8. And I check one more time just to make sure I use the greatest common factor, or the GCF. I check again. Do 5 and 8 have any common factors other than 1? And the answer is no, they do not. So my answer is 5/8. To sum it up, 1/4 plus 3/8 can be rewritten as 8 32nds plus 12 32nds, and in simplest form will equal 5/8. Awesome. Next one. We have 2/5 plus 3/7, and what I'm going to do first is, you guessed it, write it in vertical form. 2/5 plus 3/7, and I'm going to write a sum line. I'm going to get rid of this information here because I copied it correctly and I need more space. Now I'm ready to move to the next operation, which what I need to do is find a common denominator because my denominators are not the same. 7 and 5 are not the same, so I need to make them the same by writing an equivalent fraction. Think, 5 and 7 are both prime numbers, which means that the only way to find the least common denominator is to multiply them against each other. So that's what I'm going to do. I'm going to multiply this one by the opposite denominator and the same for the other. So since the opposite for this one is 7, I'm going to do 2 times 7 and 5 times 7. Next, I'll do it for the other one, and I'll use the opposite denominator again. I'll extend, and I'll do 3 times 5 and 7 times 5. Again, you see the opposite here. It's the inverse. So now I'm ready to move to the next part, which is rewrite my fractions so that the denominators are the same. 2 times 7 equals 14. Over 5 times 7 equals 35. Then I check the next one. 3 times 5 equals 15. Over 7 times 5, which equals 35 again. And I don't want to forget my addition sign or my sum line. And again, we're ready to add or subtract. In this case, we're adding. So let's add the numerators. The denominators are the same, so they won't change. Just add the numerators. 14 plus 15 equals 29. And that's over 35. Finally, we check to see if we can simplify this answer. we think about the common factors that are greater than 1. And for 29 and for 35, there are no common factors except for 1. So we're in simplest form. Already doing great. We're done with this one. We don't need to simplify. Let's do one more addition problem. One sixth plus 3/4. I'm going to rewrite it like I always do in vertical form. It's easier to work with, so that's why we do it. 1/6 plus 3/4. Sum line. Now again, I don't have common denominators, so I need to rewrite them in equivalent fractions so that they do have a common denominator. Now, if you know your multiplication facts, then you might quickly arise to the decision that 6 and 4 have common multiples, and you could multiply them against each other like this. And if you did 6 times 4, you would have 24. But 6 and 4 have a lower common denominator. The lower common denominator that they have is 12. So I'm going to use 12 for my rewriting. I make a sum line and I think about 6 times what other factor would equal 12. Now I know that my basic fact is that 6 times 2 equals 12. And because I'm multiplying this in the denominator, I also need to do it in the numerator. Now I check to see for 4. I have to think to myself, 4 times what factor would equal 12? 4 times 3 would equal 12. And because I did this to the denominator, I also do this to the numerator. It makes sure that the fraction remains equivalent. Now I'm ready to get an answer. Equals 1 times 2 equals 2 over 6 times 2 equals 12. Now the next one. 3 times 3 equals 9 over 4 times 3 equals 12. And I want to remember to put my addition sign and a sum line. And there you have it. We're ready to add. So let's do it. 2 plus 9 equals 11. And that's over 12 because the denominator doesn't change when we add and subtract with like denominators. Lastly, I check to see if I can simplify. 11 and 12 share exactly one factor greater than 1, and that's 1. So it's already in simplest form. You're doing very well. If you want to, you can take a quick break, stand up for a moment, stretch a little bit, and then get back to fractions, and this time we'll subtract. Whether you took a break or not, I'm ready to go. Let's begin. 9/10 minus 2/5. I'm going to slide this into a new format. I'm going to rewrite it to be vertical because it's easier to work with. 9/10 minus 2/5. Difference line. And I'll get rid of that. I don't need it for this. It's a waste of my space that I need to use so that you can see my work better and learn from it. Let's continue. The next step is find a common denominator and write equivalent fractions. 5 and 10 can be multiplied against each other, but there's a better way. You may have noticed that 5 is a factor of 10, which means we can use it in this scenario as the number that we're going to have as a common denominator. So we think, what factors can we multiply to equal 10? Well, 10 times 1 equals 10. And since we did it to the denominator, we do it to the numerator. Times 1. Now, it will remain unchanged, but this is to help with neatness and organization. We extend this line for this fraction now. 5 times 2 would equal 10. And we did this in the denominator, so we do it in the numerator as well. Times 2. Now we're ready to have our equivalent fractions so that we can subtract. Equals 9 times 1 equals 9 over 10 times 1 equals 10. Next one, 2 times 2 equals 4 over 5 times 2 equals 10. Now I want to make sure I move the correct operation over. If I were to add this, I'd have a completely wrong answer and we did all this work and it'd be wrong. So copy it correctly and also bring over your difference line. Now we're ready to subtract. Because the denominators are the same, that won't change. We can just look at the numerator. 9 minus 4, pay attention to the operator. 9 minus 4 equals 5. And I want to be sure that I am bringing that denominator down so that it's the same. It won't change. Lastly, we simplify. As we already saw earlier, here we already saw that 5 is a factor of 10, which means that we can simplify by dividing by 5. So we divide by 5 in the numerator and divide by 5 in the denominator. And when we finish it off, that equals 5 divided by 5 equals 1, and 10 divided by 5 equals 2. And that's a benchmark. So we know that it's in simplest form. Benchmarks are in simplest form. We learned that earlier if you had watched any videos or been in my class. Let's do the next one. The next one is 1/4 minus 1/7. I'm going to rewrite it as 1/4 minus 1/7 with a difference line because it's easier to work with when it's in vertical format. I'll get rid of this. And I'll move this up here. Easier to see. So now we see that we have denominators that are different. So we need to make them the same. We need to make them like denominators. So we think, what is the common multiple of 4 and 7? In this case, the first one that we're going to encounter is each other to make 28. So we extend the line and we multiply by the opposite. The opposite here is 7, so we're going to multiply by 7 in the numerator and the denominator. Then we check the next one. Extend the line and flip which one we're going to multiply. This time we multiply by 4 in the numerator and multiply by 4 in the denominator. Now we're ready to get our equivalent fractions. Equals 1 times 7 equals 7 over 4 times 7 equals 28. Next one, 1 times 4 equals 4 over 7 times 4 equals 28. I carry over my operation, this one is subtraction, and I write my difference line again. And finally, I'm ready to perform the operation. The denominators are the same, so it will go unchanged, and I can subtract. 7 minus 4 equals 3. And I keep my denominator, 28. Think to yourself for a moment, what's next? If you said simplify, you're right. We need to check to see if we can simplify. Think, does 3 and does 28 have a common factor greater than 1? If you said no, you'd be right, which means it's in simplest form and you're done. Wonderful job. Now you're ready to do some on your own.